Now that we can add and subtract radicals, now we're going to look at multiplying with radicals. So I've broken this video up into three main pieces. I'm going to do monomial by monomial, I'm going to do monomial by polynomial, and then I'll also, which you can't see on the screen right now, do binomial by binomial. This is going to be the property we use. We've used this property in the past, but we said if we had two things being multiplied under a radical, we could break it up each into their own radical. We use that concept to simplify, for example, something like the square root of 24. We said was the same thing as the square root of 4 times the square root of 6. Now we're going to go the other direction. We're going to say if we have radicals multiplying, we can put them together. So let's go ahead and start with these first two examples. So I have some options here. One thing I could do, if I wanted to, I could simplify each of the radicals first and then multiply. I prefer to just multiply and simplify once. The reason being is that if I simplify first and then put together, I oftentimes have to go back and simplify anyway. So I feel like if I just multiply first, that means I only have to simplify once, excuse me. So I'm going to go ahead and I'm going to see I have two of the same radicals. They're both square roots, both an index of 2. So I'm going to go ahead and multiply them together. The 5 will remain out front. 24 times 4 is 96. X to the 5th times x cubed is x to the 8th. Remember, that's one of those prior course concepts that you saw on the pretest that you had to make sure that you knew. Y squared times y cubed is y to the 5th. And now I can go ahead and simplify like I've done in the past. So I know 96 is divisible by 16. Remember, if you didn't know that, you could always use your calculator to help you out. X to the 8th, I like to go do it by grouping, but remember you can make fractional exponents. These are your notes, so make them your own. Do what works best for you. I would say if I have 5 x's, I'm going to take out 2 groups of 2, and I'll have 1 left over. And, oh, excuse me, I had 8 x's. I apologize, I was looking at my original problem on accident. So x to the 8th, I have 4 groups of 2 with none left over. Y to the 5th, I have 2 groups of 2 with 1 left over. So 16, the radical 16 is 4, so 5 times 4 is 20. I'm going to bring my x to the 4th and my y squared down, and then everything in my radical, which is 6y. And there is going to be my simplified form after multiplying my radicals together. Looking at one more example here with monomial by monomial, and then we'll move on to monomial and polynomial. First thing again I'll do is multiply these together. So I'll multiply the 2 and the 6, the non-radical terms. I get 12 cube root. 81 times 3 is 243. X to the 4th times x is x to the 5th. Again, I add my exponents, and I only have y to the 8th. And now I'm going to go ahead and simplify. So I'm going to have 12. Using my calculator, I see that 243 is divisible by 27, which is a perfect cube. So I'm going to rewrite that as the cube root of 27 times the cube root of 9. If I have x to the 5th, and I ask myself how many groups of 3 can I make, I can make 1 group of 3, and I will have 2 left over. And if I have y to the 8th, and I ask myself the same question, I can make 2 groups of 3, and I will have 2 left over again. The cube root of 27 I know is 3, so 12 times 3 is 36. I'm also going to bring my x and my y squared down, and I'm going to put everything that belongs under a radical under the same radical. So the 9, the x squared, and the y squared. And here's again going to be my simplified form after multiplying my 2 terms together, my 2 monomials together. So now the second piece, I'm going to look at monomial by polynomial. So it's going to work basically the same way, except here I'm now going to have to distribute in to each of my terms before doing the multiplication. So I'm going to go ahead and do that. So I multiply in, and I get 2 radical 3x cubed times 2 radical 8x squared, and I get 4 radical. Using what I learned up above to know that when I have radical 3x cubed times radical 8x squared, they can combine and go under one radical, giving me 24x to the 5th. Minus, again, I'm going to distribute to my back term, and I get 2 radical. 3 times 6 is 18x. Again, I add my exponents when I multiply same base to the 8th. Now I can simplify each of these terms. So I'll drop my 4 down. 24 I know is radical 4, radical 6. If I have x to the 5th and ask myself how many groups of 2 can I make since it's a square root, I can make 2 groups of 2, and I will have 1 left over. Doing the same thing to my back term, I get radical 9, radical 2, since 2 times 9 is 18 and 9 is a perfect square. I ask how many groups of 2 can I make. If I have 8 x's, I can make 4 groups of 2 with nothing left over. Cleaning this up, I get radical 4 is 2, so 4 times 2 is 8. I'm going to drop my x squared down, and I'm going to bring down my 6 and my x and keep them under the same radical. There's my first term. Minus, radical 9 becomes 3. 2 times 3 is 6. I'm also going to bring my x to the 4th out front. It's that associative the commutative property of multiplication that says it doesn't matter what order I multiply in, so I can move things around. And there's going to be my final answer. I cannot combine these because, as you saw before, I can't add or subtract unless I have the exact same radical part. So I'm going to stop there. And then we're going to move on to the last piece, which is binomial times binomial, and it's using that idea of FOIL. 2 examples of that. So on the first one, I notice that I have square root of 3x minus 2 times the square root of 6x cubed squared. Do not distribute the square, and I cannot distribute the square unless it's multiplying. Because it's adding or subtracting, I have to write it twice in FOIL. Alright, now I can FOIL, so I'll do first times first. Square root of 3x times square root of 3x is square root of 9x squared, 3 times 3 and x times x. And square root of 3x times 2 square root of 6x cubed is minus 2 times the square root of 3 times 6 is 18. X times x cubed is x to the 4th. Inside times inside. I get minus 2 square root 18 x to the 4th. And last times last, I get plus 4 times the square root of 6 times 6 x cubed times x cubed. There's my initial answer after foiling. Now I want to clean anything I can up. Well, I know that the square root of 9 is 3. And x squared, there's one group of 2 with nothing left over. Minus 2, I'm going to say the square root of 18. I don't know, so I break that up. X to the 4th has 2 groups, nothing left over. Doing the same thing to my next term. They will not always match my middle terms. X squared, again, 2 groups of 2, nothing left over. The square root of 36, I know is just 6. X to the 6 has 3 groups, nothing left over. So I have 3x. 2 times square root of 9 is 2 times 3, so 6. Moving my x squared up. Square root of 9 is 3 again. So 2 times 3 is 6. X squared minus square root of 2 plus 24 x cubed. Please remember, if you can't keep up, pause the video as necessary. And then finally, I see I have a couple like terms. These are like terms since they have the exact same variable part, the x squared, as well as the exact same radical part. So the 3x drops down, minus 6 and minus 6. Combining my coefficients, I get minus 12x squared, square root of 2. Notice again the radical and the variable part do not change, plus 24x cubed. And there's going to be my final answer. I cannot combine these. They both have an x, but this is x to the 1, this is x to the 3rd, so I must stop here. Finally, one last example. I know this is a longer video. I do apologize for that. I want to look at multiplying these here. Well, what do I notice? Well, I noticed that these are almost exactly the same, except for they differ in sign between in front of the second term. So if you remember, we've talked about situations like that before. We call these conjugates. And I know that if I am in the form a minus b times a plus b, I can FOIL, or I can use the fact that a minus b times a plus b multiplies to be a squared minus b squared, and I can skip the FOILing. So I'm going to go ahead and use that concept. So my a, I notice, is going to be 5. My b is going to be radical 6xy. So following my formula, I get a squared minus b squared. Again, remember, I could always FOIL if I'm more comfortable with FOILing. And then 5 squared is 25. My radical and my square will cancel, leaving me with minus 6xy. Since I do not have the exact same variable part, I cannot combine like terms, and I'm going to go ahead and stop here. What you will notice is that if you were to FOIL this instead, you're going to see that your first times your first is going to give you that 25. Your last times your last is going to give you that 6xy. And your outside times your outside plus your inside times your inside will be opposites and cancel out, which is why I do not have that middle term in this 5th example like I did in the 4th example. So again, I know this was a longer video. All 3 different ways so that you can multiply with radicals and different types of polynomials.